In this video, we will learn to integrate rational functions where the denominator is a quadratic. Now, quadratic means you're going to have x squared plus something in x and plus some constant in the denominator. Now, where do we begin? We begin with this idea. If you remember the derivative of tan inverse x, it's 1 over x squared plus 1, which means that the integral of 1 over x squared plus 1 would be tan inverse x plus c. Now with this, let's do some examples. So say I have 1 over, now my quadratic, I'll keep it similar to this one, but instead of x squared plus 1, say I have x squared plus 3. So how do I integrate this? Well, I'm going to see this as integral of 1 over x square plus root 3 square. Now in that case, I want to let x be equal to square root 3 tan theta. So in that case, what happens is dx becomes square root 3 secant square theta d theta. So the integral simply becomes dx could be replaced by square root 3 secant square theta d theta, and then x square becomes root 3 tan theta, this is x, you need to square that, plus root 3 square. So notice that this is going to be square root 3 secant square theta d theta divided by, now this becomes 3 tan square theta plus 3, and that will be square root 3 secant square theta d theta divided by 3 times of, you can factor a 3, tan square theta plus 1, but notice that tan square theta plus 1 is secant square theta. So we can cancel this secant square theta with tan square theta plus 1, and then this simply happens to be, so root 3 over 3, I can simplify that as 1 over root 3 integral d theta, so that becomes 1 over root 3 theta plus c, and theta is simply 1 over root 3 tan inverse x over root 3 plus c. So long story short, if you have to integrate something like dx over x square plus a square, then if you look at the previous example, a was root 3, I got 1 over root 3 and tan inverse of x over root 3. So this is going to be 1 over a tan inverse x over a plus c. And we can remember that as a formula. Now, if you have, say, something in x, so let's write down this one, x squared plus 8x plus, just pick some number, maybe 21. I want to pick something bigger than 16. Then this is going to be equal to, now notice the number, if you look at x squared plus 8x, then you know that the number that completes the square is 16. So you want to break this 21 down as 16 plus 5. And then you can rewrite the denominator as x plus 4 quantity square plus 5. So this time your answer will be, now your A is root 5, so it's going to be 1 over square root of 5, and then it would be tan inverse of, this time it's going to be x plus 4 divided by square root of 5 plus c. Now I could have said let x plus 4 be equal to square root of 5 tan theta, and I would get there. So the point is, if you can get it in this form, you have the answer. Now sometimes your finding the number that completes the square might be a little bit tricky. In that case, you may have to do a little more work. Here I chose a nice number.